going to be talking about graphing in slope-intercept form. So you can graph equations of a line by making a table and by solving for y and applying slope-intercept form. And you can write the equation of a line given a graph or a table. Yep, that's completely fine. So what exactly is slope-intercept form? Slope-intercept form is y equals mx plus b, where m is the slope of the line. Remember, slope is a change in y over a change in x, which is a rise over run. And b is the y-intercept, which is 0, comma b. Remember, for the y-intercept, x is always 0. Okay, so this next one say find the slope and y-intercept of each of the equations. So before you can find the slope and the y-intercept, you must first put it into slope-intercept form. So before you can do this, put into slope-intercept form first. Okay, Hannah, what is my slope of this first one here?
5.
Good. So remember, it's y equals mx plus b. So your slope is 5. Ian, what is my y-intercept?
3.
Yep, my b value is 3. What questions do you guys have so far before I do the next one? Okay. Mackenzie, is the next one in slope-intercept form?
No.
So what do you have to do first? Okay, so what are you going to do then? Which one are you looking at, first of all, so I know that we're on the same page? Okay, what are you going to do first on that one? We're trying to get y alone.
Subtract 2.
Yep. Is y alone after you do that? Okay, good. So first we get it into slope-intercept form. Connor, what is my slope? Good. Peyton, what's my y-intercept?
4.
Good. Okay. Next one down there, Jen. Is that in slope-intercept form?
Yep.
What do you have to do first?
Subtract 3 x from each side.
Then what, Jen?
Divide both sides by -3.
Yep, and I'm going to divide every part separated by addition, subtraction, or an equation sign to do that. So that's negative and a negative is a positive. 3 divided by 3 is 1. Negative and a positive is a negative, so that's -2. So, Myra, what is my slope? So if there's nothing in front of x, your slope is 1. There's like a little 1 there that's not actually there. What's my y-intercept, Jennifer?
-2.
And it's really important that you take the sign that's in front of the number like Jennifer did. We don't have to worry about saying +3 because when we say 3, it just means positive, right? But we need to take the sign that's in front of it, and that is -2 for that one. Okay, Tommy. Last one there. What is my slope? And what is my y-intercept, Zach? On the very last one, bottom right. It's in slope-intercept form already. Which one is the y-intercept? If it's y equals mx plus b and b is the y-intercept, which one is the y-intercept?
-3, huh?
Yeah, good. So if you don't understand this, we need to like really discuss it. So Zach, do you understand where all the parts are, the slope and the y-intercept? Oh, okay, sorry. But make sure you guys understand where they're coming from, because if you don't, it's going to be hard to graph them. All right, when you're ready, go ahead and flip to the next page. Okay, so the parent function is the simplest function in a family of functions. Every function has a parent. We're going to learn 4 different types of functions this year. Linear, which you kind of already know. We're just going to look at different forms this year that you didn't look at last year. Exponential, quadratic, and absolute value. So those 3 are going to be different for you guys. Each of them have a parent. A parent function is much like your own parents. The other functions come from them, okay? So you have some features of your parents, right? Not everything's the same, but you look like your parents in some sort of a way, hopefully. But if not, that's fine too, whatever. But my point being is that they come from the other. So they'll have the same kind of features, all right, coming from that one. The parent itself is the most stripped down one, though. If you notice here that this is the parent of a linear function, it's just y equals x, you'll notice that there's no number in front of the x, which means your slope is 1, and there's nothing added to the end of it, which means that your y-intercept is at the 0 there. So what is your slope of this parent function? What is the slope of this parent function here? Yeah, 1. Because there's no number in front, which makes it 1. What is your y-intercept of the parent function? Joe, what is the y-intercept of the parent function? Yeah, nothing's added at the end, so this is like +0 here. So oftentimes, kids get really confused when they see the parent function because it looks like there's like no numbers at all with it, so it gets a little bit confusing, right? But just remember, if there's nothing in front of x, it's 1, and if there's nothing added at the end, you can always put +0 there if it makes you feel better to find that y-intercept, okay? Whatever makes you feel better on getting those answers right. So if we're going to do our table, if we plug in these values for x, what would your y be? If you plug in -2 for x, what would y be? 1 times -2 is? -2 plus 0 still?
Yeah. Wait, no,
-2.
Right. Yeah, you're right.
It's just you're getting the same thing. Isn't it saying y is the same thing as x when it says y equals x? So if your x value is -1, what will y be? Yeah, because it's just saying y is the same thing as x. So if your x value is 0, your y value is, and so on and so forth. So if you were to plot those points, these graphs are really hard to read too. So if you have like a highlighter or something, I would take it out and just highlight the x and y axis, or a different color pen maybe, just because it makes it easier to see the x and y axis, because these ones are really hard to read. Yeah? Why did I put those in there? Whenever I do the x column, I just always choose a couple negative and a couple positive around 0. You get to make that choice because you can find any value of y by plugging in any value of x. So I just choose some from there. Again, highlight the axis so you can actually see it. It's so hard to plot otherwise. But then you can plot your points. And let me get straight edges out for you. Somebody had, I think, a ruler on their desk still. Does anybody want a straight edge? If you don't want it, you can use your ID, but does anybody want their own straight edge for right now? If you want to use your IDs, you can.
Thank you.
So that you need to use a straight edge on your homework. That doesn't have to be a ruler. It can be a ID of some sort or a gift card of some sort. That is also fine. Go ahead and take those back. Anybody else? Anybody else want one? All right. So, and then you can connect those points. And you'll see the line. So you notice the slope is 1. You're going up 1 over 1, and you started at the origin. So then it says, give an ordered pair solution of the graph. A solution is any point along the line. Or I should say on the line.
Oh.
What? Is it in pen or pencil? You can just erase it. It's okay. And then I'm going to call this y equals x and get used to labeling it because we're going to be doing transformations and we'll have more than one function on a graph next week. So it's good to get used to labeling when we have more than one function on there. So give me a solution. Give me a solution. Any solution that's along this line. Jacob? -1, -1 is a true statement. If you were to plug that in, if you plug in -1 for x, you get -1 out for y. -1 equals -1. Peyton? 0, 0. It is a point along the line. If you plug in 0 for x, you get 0 out for y. 0 does equal 0. Okay? So that's what makes it a solution. It makes that equation true. It is a point on the line. Are there questions on the parent function before we get to the next one? Yeah. Yeah, quickly. Alrighty, I'll go back. When you're ready, I'm sorry, we'll get started with the next one. Make sure you're writing everything down. All right, so this one says to graph y equals 1/3 x minus 2. So to graph, the first thing you need to do is plot the y-intercept. Notice what I said. I said plot the y-intercept, not the x-intercept, the y-intercept. Do not plot on the x-axis. So it's 0, whatever number it is. Plot the y-intercept, not the x-intercept. This is a y-intercept. The y-axis is the one that goes up and down. Plot it on that one, the one that goes up and down. Okay, I'm going to highlight my graph again just because it's not easy to see the x and y axis, so if you would like to do the same, you can. You don't want to get things wrong if you can't figure out where the x and y axis is. Oops, sorry. So remember, this is y equals mx plus b. What is my y-intercept? Maddie, what is my y-intercept?
-2.
Yeah. We're at 0, -2, so I'm going to plot a point at 0, -2. Then you will use your slope to plot at least 2 more points. Remember, slope is a rise over run, so make sure you rise and then you run. So, Evan, what is my slope in this line here?
1/3.
1/3. So that means, because they're both positive, that means we go up 1, right 3. So if I go up 1 from my point and right 3, I get here. If I go up 1, right 3, I'm kind of off the graph, but it'd be somewhere around there. So if I go down 1, which direction would I have to go? If I go down 1, which direction would I have to go to keep it a positive slope? Left 3, right? We know that our slope should go uphill left to right if it's positive, right? And it should go downhill if it's negative, so that is going uphill. And then use your straight edge to connect your points. I'm going to label this as y equals 1/3 x minus 2. Jennifer, what is an ordered pair solution of this graph? So what is a point along the line? 0, -2, which means that if you were to check it in your equation, if you were to plug in -2 for y and 0 in for x, it would come out as a true statement, right? Now, you don't have to do that on your homework, but my point is that it makes the equation true. My point is that it is a point along the line. That's what makes it a solution. Do you guys understand that? So, Tommy, what's another solution? Yep. So what's another point along that line?
The y-intercept is 0.
We already got 0, -2 up there. Give me a different one. I have 3 other points that are plotted up there, so you can use any of those.
Oh, okay. 0 and then 6. The one that's like off the
That would be 0, 6. 6, 0 is what you're saying?
Yeah.
Now, again, if you were to plug that in, 1/3 of 6 is 2. 2 minus 2 is 0. So that does make sense. All right. So, questions on graphing when you're given an equation? All right. When you're ready, go ahead and flip to the next page, and we'll talk about some tables next. Again, highlight the axes if you need to. If I need to go back, let me know. All right, if you're given a table of values and it tells you that you need to graph and write the equation, if you're going to just graph from a table of values, what do you just have to do? What does that mean you're going to have to do? Peyton? You can just plot ordered pairs. It doesn't make it that difficult. If they don't fit on your graph, you don't need to plot them. So -1, 7 doesn't, but 0, 5 does. So all I'm doing is plotting some of those points that are in there. 1, 3. 2, 1. If you do not know how to plot points, you need to talk to me. Okay, it does tell us we need to write the equation of it, though, too. So we are going to write the equation of this after we plot the points. So to write the equation, you need to know the slope and the y-intercept. So how can I find my slope? There's multiple ways we can do this, but how could I find my slope? What is one way, Lexi, that I could find my slope? What could you do? Yeah, but how can you find the rate of change? Huh? How did we find the rate of change over the last 2 days? We've been doing this for 2 days now. There's 2 different ways. You can either use the graph or the table. It doesn't matter. Rise over run. So you could just use the points and do the rise over the run on the graph. So if you go down 2 over 1, what is your slope, Lexi? Negative what? Yeah, because negative 2 over 1 is just negative 2, right? So if you were to do it that way, that's fine. Or you can see here, each time we're adding 1 and then subtracting 2, adding 1, subtracting 2, adding 1, subtracting 2. So could you have done it that way as well? Okay, so that's how you can find the slope. How about the y-intercept? How could you find the y-intercept? Peyton? So where's when x is 0? So we could do the y-intercept that way. Zach, what's another way we could have found the y-intercept? Yeah, it's way up here on the graph, right? So does it matter which way you do it? No. Quickly. You just went before class. Hannah, what is the equation?
Y equals negative 2x.
Not just y equals negative 2x.
Oh, plus 5.
There you go. So y equals negative 2x plus 5 is my equation. Give 2 ordered pair solutions of the graph. So give me an ordered pair solution, Ian, of this graph. Don't make it harder than it needs to be. Thank you. There's a table ahead of you. There's not much you have to think about here. Mackenzie, what's another one? 1 and 3. Is 5 negative 2 a solution of this function? Is 5 negative 2 a solution of this function? Jen, you're shaking your head no. Why?
Because if you're like looking at the table or even out on the graph, when you're looking at 5, your number would have to be negative 5.
Right. If you look on the graph, 5 negative 2 is not on our line, right? It's at negative 5. If you look at the table and we continue our adding 1, subtracting 2 that's going on here, that would be negative 5. Or if we just plug it in and say negative 2 equals negative 2 times 5 plus 5, negative 2 does not equal negative 5, right? You guys see that? So that's 3 different ways you can explain why it's not a function. Or not a function, sorry, not a solution of this function. What questions do you have there before we do the next one? Okay, determine the rate of change, graph the line, and write an equation in slope-intercept form. So we'll determine the rate of change as we're doing this stuff here. We'll first graph the points, so go ahead and plot some points for me. After I know where my axis is actually at, it makes it easier to plot the points. So, Evan, how could I find my rate of change? What could I do? Do rise over run, so it's going down 4, which is negative, right 2, which is positive, so what would your slope be? Yep, because you do negative 4 over 2, which is negative 2. Or you could have looked at it here. You're adding 4 each time on the y, subtracting 2 each time on the, opposite. You're subtracting 4 each time on the y and adding 2 on the x. So negative 4 over 2 is negative 2. Tommy, what's my y-intercept?
Oh, so wouldn't it be all the negative 4s?
No. Look at your graph. Where's it crossing the y-axis at? Make sure you guys are connecting your points too, guys, at the line. Where's it crossing the y-axis at? At 1. So it's 0, 1. So when x is 0, you have your y-intercept, so you could see it here on your graph, or you can look on your table, like on the graph or the table. Jacob, what's my equation then? What's your slope? Because it's mx plus b, so slope is? No, it's not negative 1. There you go. You see we went down not 4, up 2. Negative 4 over 2 is negative 2. Or you can see that here, down 4, right 2 is negative 2. Plus what? What's your y-intercept? Where's your y-axis at? What's your y-intercept? I write everything over here. Just look at the board. What does the y-intercept say? 1. Are you confused on how to write the equation? It's okay if you are you? Well, if you are, we need to know so I can help you. So, when you're writing the equation of a line, it's y equals mx plus b, right? M is your slope, which is your rise over run. B is where you're crossing the y-axis, okay? So your slope is the down 4, right 2, rise over run, negative 4 over 2, which is negative 2. So that replaces the m value in y equals mx plus b, okay? Y and x are going to stay in there. Your b value is where it's crossing the y-axis, so it's here at 0, 1, so it's at 1. So that replaces the b value in the equation. It's okay if you don't know what you're doing, just ask, okay? I don't like when you guys don't ask.
Is that a crayon?
It's actually a stylus that looks like a crayon.
Huh.
I have choices of styluses, and one of them is the Kit Pack, and I like the Kit Pack the best, so that's why I picked it. Okay, so state another solution not given in the table of values. So give me a solution, Zach, that isn't in that table. So you can't tell me negative 2, 5, 0, 1, 2, negative 4, 3, 4, negative 7, or 6, negative 11. It has to be something that is not in that table. Yeah. So continuing the pattern here, 8, negative 15. Or you could just choose any value for x. So if you give me any number, so I would just said 10, right? You can literally just plug that in for x and figure out what y is. So if I would have done that, I could have done negative 10, 2 times 10 plus 1. That's negative 20 plus 1, so that would be y is negative 19. So that is 10, negative 19. right? So that's another way you could have done it.
Did you choose blue because you have a blue crayon?
It's you, this right here?
No, that's red.
Right. And I was writing in red right there.
No, I mean like blue. Like there's blue writing up there.
Right, but I've used all the other colors too. That's not why I chose it. It's just the color that I chose. I write with every color.
But that doesn't
Pretty.
make sense.
It's a pretty rainbow note. Yeah, but this is just a stylus. It means nothing.
Well, like it should mean something.
I'm not gonna write in the same color. It's good to like be able to see the difference of things. That's why I color code everything. Tommy's so mad at me for using the wrong color with my crayon. All right, so when you're writing the equations of a line from a graph, you need to make sure you're finding exact points along the line. An exact point along the line actually meets at an exact T. So do you see how this is an exact T here? It's not like a little bit above or below it. So that's what you need to look for when you are going to be writing equations of lines, is you're going to want to make sure that your points are at an exact cross. So I'm going to take some points off of this. So that's negative 2, 3. Negative 1, 2. 0, 1. 1, 0. So I just took points off that line. Do you guys see that? It says write an equation of it. So y equals mx plus b. Tommy, I'll make it blue this time for you.
It's ruined now.
I know, it is. So, Joe, what is my slope? Be careful, close. It's going downhill, so it would be. Yeah, it's going down 1, so that's negative 1, right 1, which is positive, so negative 1 over 1 is just negative 1. Okay? Or you could have done that from the table. If you look over at the table, you're subtracting 1, adding 1, subtracting 1, adding 1, so that's negative 1 over 1. How about the b value? Where is it crossing the y-axis? Jennifer, where is it crossing the y-axis at? At 1, so it would be plus 1. Mackenzie?
Did you make it x plus 1?
Completely fine. I actually prefer that. I just am trying to give 2 ordered pair solutions of the graph. So give me an ordered pair solution. Jacob, give me an ordered pair solution. 0, 1. Jacob, give me another one. Thank you, Jacob.
I thought you were calling on Evan.
No.
You called him because you were looking at him.
No,
and
I was
so
calling on Jacob.
that's where he's like,
All right. Questions on that before we do a word problem? All right. A bowling alley charges $5 per game and $4 to rent shoes. Write an equation and graph. How much would it cost to bowl 7 games? So first we need to write an equation. So it's y equals mx plus b. So first of all, which one of those is a rate? Which one of those is a rate? Myra?
$5 per game.
So it's a dollar amount per game, right? So we know y over x is our slope. So this should be the number of games. What?
Why can't we just do 5 times 7 and plus 4?
You will for the answer, but you have to do everything else as well. That is one of the things you're going to do.
But like, later on in life, when will we ever need to use a graph?
I get it, okay? I get it. But you also need to be able to read graphs. Graphs are in other places in your life, so you need to understand graphs. So to be able to graph one, you should be able to understand how to read one. I'm sorry.
Hey.
You may not have to create one, but you should know how to read one. Okay, so we said our rate is 5, which means our slope is 5. Where do you start off paying? What do you start off paying, guys? Yeah.
$4.
Good job, Jen. No matter what, you're going to pay $4 for the shoe. You're not paying $4 per game for the shoes. You're just, $4 the first time you walk in. It's $5 per game, though. So you have y equals 5x plus 4. So if we graph that, we start at 4, and we go up 5 over 1. Up 5 over 1. Okay, should you have your arrow going in both directions? Should your arrow continue on this way? No, you can't have negative games, right? That's why the first quadrant is the only quadrant given here. It's because you can't have negative money or games. You're not going to be able to play if you have negative money. And then it says, as Tommy said, why can't we just do this from the beginning? It says, after 7 games. Well, is that x or y? That is x. So, we can plug in 7 for x. So what would that be as a sentence? What would that be as a sentence, Peyton?
It will cost $39 to bowl 7 games.
So you couldn't see that on the graph, so you have to use the equation. All right.